This is Mrs. Naslin, and today we'll be doing Fluency Lesson 6, Multiply and Divide with 6. Our learning targets for today are, I can explore patterns in sixes, count bys, multiplications, and divisions. And I could develop strategies for finding sixes multiplications. So first we're going to look at the patterns that we see in our sixes. So one set of 6 is equal to 1 times 6, which is 6. Two sets of 6s is 2 times 6, which is 12. 3 times 6 is 3 times 6, which is 18. 4 times 6 is 4 sets of 6, which is 24. 5 sets of 6 is 5 times 6, which is 30. 6 sets of 6 is 6 times 6, which is 36. 7 sets of 6 is 6 times 7, which is 42. 8 sets of 6 is 8 times 6, which is 48. 9 sets of 6 is 9 times 6, which is 54. And lastly, 10 sets of 6 is 10 times 6, which is 60. Now go ahead and take a look and see if you can think of any patterns that you might see. You can think about the other patterns that we've seen earlier in our previous numbers that we've studied in our 1s, our 3s, our 5s, our 9s. See if you see any patterns that might relate to those. We'll talk about the patterns that we see. All right, so first let's just go ahead and read our products. We got 6, 12, 18, 24, 0, 6, 2, 36, 42, 48, 54, and 60. One pattern that you'll see is kind of cool is I'm going to actually write the 3 count bys that we did a long time ago. I'm going to write these on the side. So, and you could say these out loud with me. If we're counting by 3s, we've got 3, 6, 9, 12, 15, 18, 21, 24, 27, and lastly 30. And I want us to compare the products of our 3s to the products of our 6s. So I'm going to underline the ones that are the same. All right, we've got 6 and 6. No 9s, but we have a 12 and a 12. No 15s, we have an 18 and an 18. No 21s, but we also have a 24 and 24. No 27s, but we also have a 30. So there's one pattern that you may not have caught, is that our 3 count bys, every other of our 3 count bys fits a 6. And if you think about it, it makes sense, right? If we double our 3s, we're going to get 6s. So that's a strategy you can use. If you know your 3s, you can double them to help you figure out your 6s. So that's a great way to help you with your 6s. Let's see. All right, next we're going to keep looking at other patterns. One thing that you'll notice is that in our 6 count bys, they're all even. All of them are even. Another pattern that's kind of interesting is that if you ignore the 10s and you look at these, you look at like 9 times 6 is 54. You look at the first one, 6 plus 54 is 60. 8 times 6 is 48. If I add that to 12, I also get 60. 42 plus 18 would give me 60, and 36 plus 24 also gives me 60. So that's kind of a cool little pattern. Another thing that if you draw a line, see if I can draw a straight line for you. I don't know if I can do that, but we'll try. If I draw a straight line here and I divide the 5s, and we look above and below the line for patterns. So you might see in the 1s place we've got 6, 2, 8, 4, 0. and then it starts over at 6, 2, 8, 4, 0. Another pattern that you might see is that if you look at the corresponding spot above and below the line, so if I take, you'll notice that if you look at the corresponding spot, so the first above the line and the first below the line, they're exactly 30 apart. So 6 to 36 is 30 apart. So if I took 36 minus 6, I'd get 30. 12 to 42 is also 30 apart. 42 minus 12 is 30. 48 minus 18 would give me 30. 54 minus 24 would give me 30, and 60 minus 30 would give me 30. So there's some really cool patterns that exist when you look at the sixes. Now let's take a look at the division version and see if we see any patterns that exist in those. So you'll take a look here. Couple patterns you might notice in our first set, that all of our products equal 6. In our second set, all of our divisors equal 6. Let's see, those are kind of the big patterns that I see. If you see other patterns, that's great. Again, it's a good way, looking at the patterns that exist is a good way to help you memorize it. If you can see those patterns and kind of internalize them, sometimes it'll help you learn and memorize the actual fact family. All right, now we're going to talk about some strategies we can use to help us with our sixes. We're looking specifically at the problem 6 times 6, but these strategies would work with any of our sixes. The first one is one that we've reviewed a couple of times. The idea of doing your 5s first. Most people know their 5s, and you can use those to help you figure out things you don't know. So let's say I'm trying to find 6 times 6, and I know what 5 times 6 is. So if I know that 5 times 6 is 30, and I want to get to 6 times 6, all I have to do is add 6 more. So I say 5 times 6 is 30, then I can say plus 6 more is 36. So we can draw the conclusion then that 6 times 6 is 36. Another strategy you could use is doubling your 3's, and we kind of mentioned this earlier. So if you know one of your 3's, let's say that you know that 6 times 3 is 18, and you're trying to get to that 6 times 6, well, if I know that 6 times 3 is 18, and I double it, so if I say 18 plus 18, I also get to 36. So doubling your 3's can help you figure out some of your 6's. The last strategy would work with any of your multiplication facts, but you can make it into the smaller ones. And I'm going to do this little fast array, just kind of prove that this works. But let's say again, I'm trying to find 6 times 6. Equals 36. If I know that 4 times 6 equals 24, okay, so 4 times 6 equals 24, and I know that 2 times 6 equals 12, I can add those two numbers together. So if I say 24 plus 12, guess what I get? I end up getting 4 plus 2 is 6, 2 plus 1 is 3. I end up getting that 36. So you can break it up into pieces that you do know and add them together. And again, we know that 6 times 6 is 36. You can see that it works. So those are some strategies you can use with your sixes to help you solve. Lastly today, we're going to introduce the idea of a function. A function is a mathematical rule. And a rule can be made up of words, numbers, or words and numbers. So for example, a ladybug has 6 legs is an example of a rule. We know that ladybugs have 6 legs. So if you look at this function table, it shows, okay, we've got 1 ladybug, it has 6 legs. If I've got 2 ladybugs, it has 12 legs, and so forth. Now, what you want to do is try to figure out what the rule is. How do I move from 1 to 6? Or how am I moving from 3 to 18? A hint that I can give you is that if the number is going up, it's either going to be that it's going up because you're adding, or it's going up because you're multiplying. If it's going down, then it would be, so if this is if the number is going up. If the number is going down, it's either going to be that it's subtracting or it's dividing. So we look at our numbers here and we think, okay, 1 to 6. Is the number going up or is it going down? Yeah, it's going up, right? 2 to 12, it's going up. All of these are going up. So then the question is it something that I add to it or is it something that I multiply? And some of you are jumping right away and say, oh, Mrs. Naslin, of course, it's something you're multiplying. We're multiplying by 6, right? 1 times 6 is 6. 2 times 6 is 12. 4 times 6 is 24. So in order to go from here down here, I am multiplying by 6. Okay? So explain how you would use the table to predict the number of legs 10 ladybugs would have. So if I know the rule is that I multiply by 6, if I had way out here, and I'm going to go ahead and erase this for a second, way out here, if I had 10 legs, instead of 6 here, now I've got 10, what do I have to do? I use my rule and I multiply by 6. What is 6 times 10? You said 60, you're right on, right? So if I had 10 ladybugs, I would have a total of 60 legs, right? So how many legs do they have altogether? 60 legs. So that's kind of just a quick introduction of what a function table looks like, and that you can make up a rule. In our case, our rule was you have to multiply it by 6 to move down. So we'll come back to that many times, but kind of a quick introduction on what a function table is. So today we talked about our sixes and some strategies we can use to memorize our sixes times tables, and then we also talked about an introduction to a function table and rules.